that's a little bit more crazy than 2.
Okay, so let's get rolling here again. It was pointed out to me, and I want to correct it before we move on, that at the last example there, I had messed up. This was actually 14,400, so this would divide out to be 1,440 milliliters. So just in case you're looking at the recordings and wondering where the heck did that come from, that was a mistake. Okay, so some examples to look at just to kind of prove, some of you mentioned you really like the formulas because you like having that set formula. I like to throw some counter examples out there as to why I don't like the formula. So let's say the doctor orders 0.08 grams phenobarbital. And the bottle, the label, is elixir GRSS per milliliter. So first of all, what does GRSS mean? What's SS mean? 1/2. Roman numerals, yeah. A couple of you had it. GR is, of course, grains. That's a half grain per milliliter. Orders are in grams. Well, I don't see grams anywhere in this. So the first thing we have to do with that doctor's orders of 0.08 grams is we are going to have to convert it. I'll put grams on bottom and I'm going to convert to grains. 1 gram is 15 grains. So the grams are gone and we're in grains. Now I can use the information on the label. I've got to get rid of the grams. 1/2 gram equals 1 milliliter. 1/2 gram per milliliter. And now the grains are gone. 1/2 grain per milliliter. So now we're going to multiply across the top. 0.08 times 15 is 1.2. That'll be milliliters over 1 times 1 times 1/2 is 1/2, or 0.5 if you want to write it that way. 1.2 divided by 1/2 is going to be 2.4 milliliters. So you would administer 2.4 milliliters to that patient. Okay. You might also... Anybody have any questions on that one? I know it's kind of weird to have the grains in there.
Is that common in medicine?
It still is, yes.
Really?
It still comes up.
Okay. You can make it worse than
What's that? Call the pharmacy, make them figure it out. Let's say the order is for 600 milligrams of Motrin. On the label, GRV tablets. In your notes, see if you can figure out how many tablets to administer. Okay, so we have the 600 milligrams, the doctor's orders. Now in our first conversion, we're going to have to get rid of milligrams because that's what we have. We need to get it to either tablets or grains. Well, we know there's a relationship between milligrams and grains. It is 1 grain is 60 milligrams. Now the milligrams are gone. And now our label allows us to go from grains to tablets. Grains are going to go on bottom. So tablets have to go on top. What numbers go where? GRV means 5 grain tablets. 5 grains per 1 tablet. So now the grains cancel out. We have 600 times 1 times 1 tablet is 600 tablets. 1 times 60 times 5 is 300. That divides out to be 2 tablets. Doctor orders 300 milligrams of medication. On the label, you have GRSS per fluid ounce. And the syringes that are available all measure in milliliters. So we need to know how many milliliters. This one may be just a little bit cruel, but very practical, very possible. So we start out with the doctor's orders, 300 milligrams. That will be over 1. Well, we have milligrams, so that's what we're going to get rid of. So milligrams on bottom. But we don't have any conversions. The label doesn't mention milligrams, so we have to get something mentioned on the label. Label mentions grains and fluid ounces. Now, milligrams is a measure of mass or weight, so that would have to go with grains, because fluid ounces is a measure of capacity. What's our relationship between grains and milligrams? 1 grain is 60 milligrams. So we have now converted to milligrams. The next conversion, we have to get rid of the grains. This is where the label takes us from grains to fluid ounces. What numbers are going to go in here? Got 1/2 grain, 1 fluid ounce. Grains are gone. But we're not done yet. We don't want to give the dosage in fluid ounces. We want it in milliliters. Both of those are units of capacity, so we can convert between them. 1 fluid ounce is approximately 30 milliliters. Depending on where you look, it's either 30 or 29.9. We're going to use 30 because it's easier. So now we have 300 times 1 times 1 times 30 is what, 9,000 milliliters? 1 times 60 times 1/2 is 30, which gets us down to 300 milliliters to administer. Any questions?
That kind of stuff we're gonna test. A little complicated.
That depends. You got 2 weeks to either, upset me or... Sorry, no. There will be stuff on the test that involves grains. I will guarantee you that. There will be stuff that involves fluid ounces. So knowing those conversions is important. Okay. Next step I want to look at is I want to look at IV flow rates. And of course, you guys all know that an IV, there's 2 types of administers through an IV. There is the standard drip, which is the slow, steady over time. And then there's a bolus, which is a injection directly into the line that is a large amount of medication that immediately goes into the system. We're only looking at that slow, steady IV injection right now. So what we want to look at is, let's just start out with simple conversions here of time. So if we have an order for 2,000 milliliters over 8 hours. Now a flow rate can be given in a lot of forms. So for right now, I just want this in milliliters per hour. That's our first step. And in that case, this is really a simple matter of writing out the rate and converting it to a unit rate. 2,000 milliliters over 8 hours. How do I know that the milliliters go on top and the hours on bottom? It's milliliters over hours in the units. The units tell me that the milliliters have to be on top and the hours on bottom. And to make this a unit rate, in other words, unit rate just means the fraction is just in the units and I don't have a fraction with the numbers. All I have to do is divide this out. 2,000 divided by 8 is 250. So this is 250 milliliters per hour. Makes sense. 2,000 milliliters over 8 hours, you divide by 8, you get 250 milliliters in a single hour. Now what might be a little trickier would be if the order is $150 milliliters over 20 minutes. And again, we want this in milliliters per hour. So we do have the 150 milliliters over 20 minutes. This time there is a conversion involved because we don't want it in milliliters per minute. We want it in milliliters per hour. So I have to get rid of minutes and go to hours. Why did I put the minutes on top this time? Yeah, because the minutes started out on bottom. So they have to cross cancel out. This is the dimensional analysis again. It works for other types of problems other than just a dosage calculation. This time the dosage is already a rate, so we don't have to put it over 1. So the minutes cancel out. We have 150 times 60, which is what, 9,000? Is that right? Milliliters over 20 hours. And we're going to divide that out now. 9,000 divided by 20 is that 450 milliliters per hour. So that's one of the reasons why I am so attached to dimensional analysis, is it works for anything. Once you get good at it, it works for pretty much everything. So let's say we have a flow rate of, or orders for 1,500 milliliters over 6 hours. In your notes, find the milliliters per hour for me. Okay, this is just a case of dividing it out. 1,500 milliliters, divided 1,500 divided by 6 is 250 milliliters per hour. A little bit trickier might be this one. in order for 2,400 milliliters over 45 minutes. Once again, find that flow rate in milliliters per hour. So we start out 2,400 milliliters for 45 minutes. Let's get rid of the minutes. So 1 hour is 60 minutes. The minutes will cross cancel. If you wanted to, you could cross cancel the numbers too if it made it easier. Usually with calculators, it's easier just to multiply it out. So 2,400 divided or times 60 is going to give us 144,000, and then divided by the 45, 3,200. How many of you came up with 3,200 milliliters per hour? Perfect. So that's actually quite fast, by the way. That'd be a little hard to do. You're running by 300 drops per minute there. Pretty much a steady stream. So anyway, let's say your orders are for 3,000 milliliters over 6 hours. Let's find our flow rate in milliliters per minute. That changes things now. So this is 3,000 milliliters over 6 hours. We need to get rid of the hours and go to minutes. So 1 hour is 60 minutes. So now the hours divide out, and we have 3,000 milliliters on top over 6 times 60, 360 minutes. So 3,000 divided by 360 is 8.33 milliliters per minute. Now, when we're talking milliliters per minute, for the most part, we're going to round to 2 decimal places, by the way. Let's say our order calls for 600 milliliters over 40 minutes. Find it in milliliters per minute. This one's quite simple. 600 milliliters over 40 minutes. You divide that out, and it is just going to come out to be 15 milliliters per minute. 600 divided by 40 is 15. Any questions so far? So if our order is for 270 milliliters over 45 minutes, 5 milliliters per minute. So 270 milliliters for 45 minutes. All we have to do is divide it out. What do we get? 6 milliliters per minute. Very good. So another one for you to try. The order is for 3,000 milliliters over 9 hours. Find that in milliliters per minute. So 3,000 milliliters over 9 hours. We have to do the conversion. 1 hour is 60 minutes. So the hours are gone. This is now 3,000 milliliters. Over 9 times 60 is 540 minutes. So 3,000 divided by 540 is 5.55. So 5.56 milliliters per minute. How many got that? Anybody lost on how we're getting these? Or is anybody not sure how we're getting these that wants me to go over more examples? Okay. Well, the next step is to add in a drip rate or drop rate, called drop factor. A drop factor depends on the viscosity of the fluid. Water, I believe, is, I had this one, I used to know it. Where's my drops per milliliter for water? It's somewhere between 15 and, I know it's 60 drops per teaspoon. I don't remember what is drops per milliliter anymore. Because a teaspoon is 5 milliliters. So it's 12 drops per milliliter is water. Many of our medicines that we deliver are thinner than water, so it's more than 12 drops. Some are a little bit thicker, so it can be down to 8 to 10 drops. But the drop factor is the number of drops of a medication to get 1 milliliter, or to get a given volume of fluid. It could be drops per teaspoon or drops per fluid ounce if we're using standard units. Since we're pretty much in metric all the time for medical, it's usually drops per milliliter. Now, GTT is the abbreviation for drops. So a standard drop rate might be, well, water would be 12 drops per milliliter. So if we have an order for 2,000 milliliters to be administered over 8 hours. A medication with a drop factor of 15 drops per milliliter. So it's a little bit thinner than water. Find my flow rate in drops per minute. If you're manually setting an IV, it's generally done in drops per minute. If you're using an infuser, it's generally done in milliliters per minute. So we have 2,000 milliliters over 8 hours. We need to get rid of both the milliliters and the hours. It doesn't matter which one first. I'll get rid of the hours first. We'll go hours to minutes. 1 hour is 60 minutes. So the hours are gone. We still need to get rid of milliliters. Milliliters will go on bottom. And we have milliliters to drops. And it is 15 drops per 1 milliliter. Milliliters are now gone. So we multiply this out. 2,000 times 1 times 15 drops is 30,000 drops. On bottom, 8 times 60 minutes times 1 is 480 minutes. So 30,000 drops divided by 480 minutes is 62.5. 62.5 drops per minute. Any questions? Let's do another example. Let's say we have an order for let's see here. $1,500 milliliters to be administered over 6 hours. for a medication with a drop factor of 20 drops per milliliter. Find drops per minute. So again, 1,500 milliliters over 1. Or sorry, not over 1, over 6 hours, I should say. We have to get rid of the hours. I'll go to minutes. 1 hour is 60 minutes. So we're now rid of the hours. We have to get rid of milliliters. So milliliters on bottom. And we're switching to drops. So we do have the drops per milliliter. 20 drops is 1 milliliter. Milliliters is gone. So 1,500 times 1 times 20 is 30,000 drops over 6 times 60, 360 minutes. Giving us 83.33 drops per minute. Now this is something, if you're in the ADN program, they'll cover with you there, the rounding. It depends on the device. If you are using a manual setup, you would always round to the nearest drop. So this would be rounded as 83 drops, and this would be rounded as 63 drops to the nearest drop. If you're using an infuser, some of your infusers, we said, go to milliliters per minute. Others do use drops per minute, and many of the infusers would go to 1 decimal place. So you could leave this as 62.5. This would get rounded to 83.3. Again, that's something, I'm not an expert in the equipment you're going to use, so I'm not going to get into that. I'm just mentioning it so you know that once you actually get into it in a dosage calculation course, there will be different rounding depending on the device you're using. Okay, so one for you guys to try. So our order is for 1,200 milliliters to be infused over 8 hours. For medication with a drop factor of 12 drops per milliliter. Find drops per minute. So 1,200 milliliters over 8 hours. We'll get rid of the hours first, going to minutes. So 1 hour, 60 minutes. Get rid of the milliliters. They're on top, so we're going to put them on bottom. Go into drops. 12 drops per 1 milliliter. So our milliliters are gone. So multiplying 1,200 times 1 times 12 drops is 14,400 drops. 8 times 60 minutes is 480 minutes. So 1440 divided by 40. I took a 0 off of each one of them.
Oh, okay.
I'm being lazy.
You're a step ahead of me.
I'm being lazy and saving a couple of keystrokes. So it divides out to be 30 drops per minute. How many of you got 30 drops per minute? Beautiful. Good deal. So now the next step would be possibly adding it might be in order for 6,000 units over 30 minutes. The label states a 1,000 units per gram. A drop factor of, sorry, 1,000 units per gram, 1,000 units per liter. Sorry about that. 1,000 units per liter. A drop factor of 10 drops per milliliter. So, 6,000 units over 30 minutes. At least this time we don't have to convert the hours because it's already in minutes. But we do have to get rid of units. It's 1,000 units in 1 liter. And unfortunately, we got to get rid of liters. Go to milliliters. 1 liter is 1,000 milliliters. And now we got to get rid of milliliters to go to drops. 10 drops in 1 milliliter. So now we have 6,000 times 1 times 1,000. Now here's what I would do here. I've got 1,000 here and 1,000 here. I'd cross cancel it out. Make it a little easier on myself. So now I've got 6,000 times 10 drops is 60,000 drops. Over 30 minutes times 1 is 30 minutes. Which is going to give me what? 2,000 drops per minute. Okay, so obviously that's not a very practical one, but you guys get the point. So let's say we have a medication that states 1.5 milligrams per kilogram per hour. So we first have to figure out the patient. Well, we first need to know what the patient's weight is. If the weight is given, let's say as 30 kilograms, there's nothing more we need to do other than set up the proportion. The problem is there's 3 items here. There's milligrams, kilograms, and hours. We're going to ignore the hours for right now. Well, everything we're going to be doing is per hour. This is 1.5 milligrams per 1 kilogram. Now, the easiest way to do this is to use a proportion. How many milligrams would that be for 30 kilograms? Cross multiply and divide. 1.5 times 30 is 45. Divided by 1 is 45. That would be 45 milligrams. So this patient would receive 45 milligrams. You got to remember that it is still per hour. So let's say the label states "4 milligrams per kilograms per 6 hours." Patient comes in at 121 pounds. First thing we have to do here, since this label is in milligrams per kilogram, we have to get the patient's weight in kilograms. Now, the conversion between pounds and kilograms, anybody remember? 2.2, very good. To get from pounds to kilograms, you're going to have to divide by 2.2. So 121 divided by 2.2 is 55 kilograms. So this patient is 55 kilograms. So now it's 4 milligrams per kilogram per 1 kilogram. And again, usually set this up in a proportion. it'll be milligrams on top and kilograms on bottom so that the units stay the same. The 55 kilograms then goes on bottom. We cross, multiply, and divide. 4 times 55 is 220. Divided by 1, that's 220 milligrams. So this patient, we got to be careful to make sure we list this out. What's the dosage for this patient? Perfect. 220 milligrams, and we have to remember our time frame for 6 hours. So in your notes, if the label reads 250 micrograms per kilogram per 4 hours, for a patient who weighs 99 pounds, find the dosage. So what's our first required step?
Find the kilograms per milliliter.
Perfect. We're going to divide by 2.2, which is going to give us that this is what? Is it 45?
Yep.
45 kilograms. Then what? 250 micrograms over 1 kilogram. Perfect. That's per kilogram. So over here, I'm just going to label it. Micrograms on top because the units have to stay the same. Kilograms on bottom. So now it's obvious where our 45 kilogram patient has to go. It's on bottom. So 250 times 45 is 11,250. Divided by 1 is 11,250. Now that's micrograms. Milligrams, we're just going to move it over 3 spots. 11.25 milligrams. From micrograms to milligrams, you divide by 1,000. Remove the decimal point 3 spots. So that would be 11.25 or 11,250 micrograms, 11.25 milligrams for 4 hours. Any questions? Okay, well, on top of what we talked about last week, this week we have page 172 through 173, 1 through 9, the odds. Also page 178 through 179, 1 through 21, the odds. And the rest of it we'll wait till next week. So the test will be 2 weeks from today.